Today we're going to cover section 4, and in this section we're going to learn how to graph polynomial functions. The first thing you should be aware of is the end behavior of the polynomial function. When the exponent is even and the x variable is positive, the end behavior takes on the parabola. So both of the ends of our graph are going to be going upward. When the variable x is, or your variable is negative and the exponent is even, then the end behavior will be going down. When the exponent or the degree is an odd number, the end behavior, the far left 0 will be going down and the far right will be going up. When the variable is negative and the exponent is odd or the degree is odd, it's like the reflection. So this would be going up and this one would be going down. It's taking on the shape of the x cube. So remember that moved like that, and that was the parent function. These are going to be the steps that we are going to follow in order to graph our polynomial function. Just like we did in lesson 3.3, we are going to be finding the zeros. Now, if the function can be factored, you should always attempt that first. It will be a lot faster way to find your zeros. However, if it's too large of a polynomial, then you will list the possible zeros and begin your synthetic division process. What we're also going to see in lesson 4 is we'll be using our calculators to find some of the more difficult zeros, and then we can, once we find the rational zero, then we will begin our synthetic division process. We will also plot our end behavior, which is what we discussed on the previous slide. We will find the y-intercept by plugging in x equals 0 and solving for y. On the next slide, I will be addressing the multiplicity. Essentially, what multiplicity is the number of times a factor shows up. Then what we will do is pick additional points. When we're not using our calculator, we will use the remainder theorem. If you're using your calculator, you can hit the second button and then hit graph, and you will get your table of additional points or additional coordinates from your calculator. So, but for the quiz, you'll be using the remainder theorem to get your additional points. Now, you could plug in your values of x into your original polynomial. However, that may take a lot longer than if you were to use the remainder theorem. So for multiplicity, what we're doing here is we're going to check out to see how many times a factor shows up. And what we'll be looking at is the exponent. When our exponent is an even number, we're seeing that it's an even multiplicity, and it's essentially bouncing off the x-axis. So for example, if we had a factor here that was x plus 1, when I solve it, I get x equals 1, and let's say it had an exponent of 2, it would bounce off the x-axis at -1. However, when it's an odd multiplicity, it's going to run through the axis. So we'll see this later on in some examples when we have a factor appear more than one time. So let's take a look at our first example. Again, what we need to do is first check to see if it could be factored. The only way that I could possibly factor a 4-term polynomial would be to use factor by grouping. However, if I take a look at this, grouping is not going to help me. So I need to do a synthetic division problem. Now, if you were using your calculator, You could also key this into your calculator, hit the graph button and see where your zeros are. You could use your trace feature to pinpoint your zeros. However, for this one, for this examples that I'm going to do in this notes, I'm not going to use my calculator. I'm actually going to do it all algebraically. So what I need to do here is I need to list all of the factors of my last term and all of the factors of my first term. By doing this, I'm going to make a list of all of my possible zeros that I could use to test using synthetic division. So the factors of negative 15 are plus and minus 1, plus and minus 3, plus and minus 5, and plus and minus 15. The factors of my first term are just plus and minus 1. I now need to simplify this fraction. However, because my denominator is 1, all of my possible zeros are just going to be the factors of that negative 15. So now I'm going to choose a number from this list, and I'm going to begin my synthetic division process. I always like to start with 1 or negative 1. But it's up to you as long as you choose a number that's in here. So this is plus and minus 5. So if I decide to do a synthetic division problem using the number 1, I'm going to take my coefficients. I'm going to put them here in my synthetic division box, and then I'm going to begin my process. I'm going to bring down the first term, I'm going to multiply, and then I'm going to multiply again. I've already added the column, add the column, multiply, add the column. Now, in order for 1 to be a 0, I would have needed to get a remainder of 0. However, if you remember from the previous slide, the steps that we need to follow, the last step is to find additional points. And remember, I told you that we would use the remainder theorem to find those additional points. So what I'm going to do is I'm going to take this coordinate and I'm going to put it over here to the side. This could be one of my additional points that I use for step 5. Now, again, my process here was to find zeros. I didn't find 1 when I used 1 in my synthetic division problem. So now I'm going to try another number from my possible list here. So now I'm going to try negative 1. So I'm going to, again, put my coefficients in here. And I'm going to divide this time by negative 1. I'll bring down the first term. I'm going to multiply, add the column, multiply, add the column, multiply, and this time I was successful. I did get a remainder of 0. I am now going to add in my variables, and now I have a quadratic equation that I can actually solve by using one of the tools that I know for quadratics. I can either factor this, use completing the square, or quadratic formula. I'm actually going to factor this. It is factorable. Anytime my polynomial is factorable or my quadratic, I'm going to factor it. It's a lot faster process than completing the square or quadratic formula. I have now factored this into x plus 5, x minus 3. I now set each of the factors equal to 0. And this will now give me my additional 2 zeros or out of the 3 that I'm looking for. Now, remember, if you go back to the beginning here, this degree in my polynomial is going to tell me how many zeros I need to find. It's also going to tell me my end behavior. So from the very first slide, remember when it was x to the 3rd power, when it's an odd exponent, remember your end behavior, the far left 0 goes down and the far right 0 goes up. So I have now found my 3 zeros. Remember, the third one was the one you used in the synthetic division. So these are my 3 zeros. These are also my 3 x-intercepts. So I'm going to graph negative 5, 0, 3, 0, and negative 1, 0. Also in my steps for graphing, remember it said to find the y-intercept. So remember you're going to plug in x equals 0 into your original problem. My original problem was f of x equals, so I'll change that to y. So x to the third plus 3x squared minus 13x minus 15. I'm going to replace all of my x's with 0. I will simplify this down. But again, remember, it's going to be that constant on the end. So my y-intercept, again, as a coordinate, is the order pair 0, negative 15. So I've now found my 3x intercepts, my y-intercept. So I'm going to go ahead and put those on my graph. I'm also going to add in my end behavior. So I'm going to graph the negative 5, and I'm going to make my graph go by 2's so I can get my y-intercept on here. Because remember, my y-intercept was negative 15. So I'm going to go by 2's, 2, 4, 6, 8, 10, 12, 14. Negative 15 is right there. My negative 5, 2, 4, and then negative 5 here. And then I'm going to graph negative 1, and then positive 3. So I've got my 3x intercepts, my y-intercept. So now what I need to do is I need to find additional points in between each of my zeros. So I need to find an additional point in between here, which is negative 5 and positive 1. So I'm going to do a synthetic division problem so I can use my remainder theorem to get my additional point here. So I'm going to plug in, I could plug in negative 2, negative 3, negative 4, any number or even a fraction that's in between my two zeros of negative 5 and negative 1. So I'm going to plug in negative 3. I'm going to take my original coefficients here, and then I'm going to divide. So I'm going to bring down, I'm going to multiply, and then I'm going to add that column. I'm going to multiply. I'm going to add the column and then multiply again, giving me 24. So my additional point here between these two zeros is the order pair negative 3, positive 24. Now, if you recall from the beginning, when I was first trying to find my zeros, remember the first time I did it, when I used 1, it didn't work, but I did get an additional order pair here. So I'm going to go ahead now and graph these two additional order pairs, and then I'm going to connect my points. So I'm going to add in the 3 and negative 24. My negative 3 and 24 is going to be way up here. So negative 3, positive 24. And then I also have 1 and negative 24 or down here. So this could be my 1, negative 24. So now I can connect. Remember, my end behavior is this point goes down, this one will go up, and then I'm going to connect the points in between. So I'm going to come up here to the negative 3, down to the 0, down to the y-intercept, down to that additional point, and back up. So this is my graph of my polynomial function, x to the third plus 3x squared minus 13x minus 15. Let's try another example. Again, I need to find my zeros. This time what's nice is it's already factored for me. So I'm going to take each one of my factors and set them equal to 0. So x squared equals 0. This would give me plus and minus 0, but there's no such thing as a negative or a positive 0, so it's just x equals 0. Then x plus 1 equals 0, subtract the 1, x equals negative 1, and then the last factor, set it equal to 0, solve it, x equals 1. I also need to find my y-intercept. So I would plug in x equals 0. So 0 squared, 0 plus 1, 0 minus 1. Notice when I go to do this, as soon as I got a 0 here, anything times 0 is 0. So my y-intercept occurs at the order pair 0, 0. My end behavior of this function, notice that I should have 4 zeros here. Technically, this should have given me 2. It's going to bounce off the 0. And then I have 2 more here. So my end behavior is based on x to the 4th. So this takes on the shape of the parabola. I still needed to find an additional point. So you're going to see, or 2 additional points. Let me go ahead and put the 3 zeros on here and my y-intercept. So my 3 zeros are occurring at -1, 0, and +1. My end behavior on these end zeros are going up. I need to find additional points in between here and here. So notice this is from -1 to 0 and from 0 to +1. So my additional points that I need to find are, I'm going to use x equals 1/2, and I'm also going to plug in x equals -1/2. So I'm going to go ahead and plug it back into the original. It's in factored form, so I'm not going to use the remainder theorem here. So I'm going to do 1/2 squared, 1/2 plus 1, and then 1/2 minus 1. I get 1/4. This is going to give me 3/2, or 1.5. This is going to give me -1/2. I'm going to multiply them as fractions. This gives me -3/16. When I go to divide 3/16, I'm going to end up getting, if I try to get it as a decimal, it's about 0.18. So again, this is close to about 1/4 for me, or -1/4. So I'm going to plot this about 0.2 negative. Same thing here. I'm going to plug in -1/2. I'm going to square it. -1/2 plus 1, -1/2 minus 1. This gives me +1/4, +1/2, -3/2. Again, it's giving me -3/16. So the 2 additional order pairs, 1/2, -3/16, and 1/2, -1/2, -3/16. So this is just dipping below the x-axis. Erase the blue there, and then you can see that it's just scooping down just slightly. So this would be the graph of this polynomial function. Let's try number 3. Additionally, this one is also already factored for us. So I would solve each one of the factors. This gives me x equals 0. This gives me x equals 5, x equals -3, and x equals 1. Notice I should have 5 zeros here, so I'm going to base my end behavior on x to the 5th. So it would end up like that. And then I'm going to find my y-intercept. Again, when I make x equal 0 and I plug that into the original, again, I get y equals 0. So far, we have found the x-intercepts and the y-intercept. So I'm going to go ahead and put those on the graph. Now notice that I didn't provide a coordinate plane because my additional points are going to go way off of the graph. So I'm going to put in the 0. I'm going to put in 5, +1, and -3. I'm also going to put in my y-intercept, which was already on here. It's 0, 0. So remember, I need to find additional points in between. So I'm going to look for a point in between -3 and 0. So I'm going to plug in -2 into the original. So -2 squared, and then it'll be negative 2 minus 5, negative 2 plus 3, and negative 2 minus 1. So, and this is squared, so 4 times negative 7 times 1 times negative 3 gives me positive 84. So that additional point is at negative 2, positive 84. Then I can also pick a point in between 1 and 5. For this one, I'll plug in 3. Now, the 0 in between here, I'm going to also pick a point here. I'm going to plug in 1/2. So 3 squared. And then here gives me 3 minus 5, 3 plus 3, and 3 minus 1. So 9 times negative 2 times 6 times 2. I'm going to multiply these two first. This gives me 54 times negative 4, 16, negative 216. So this order pair is 3 and negative 216. I'm also going to plug in 1/2. So 1/2 squared, 1/2 minus 5, 1/2 plus 3, 1/2 minus 1. So 1/4 times negative 4.5 times 3.5 times negative 1/2. So here, when I do this, I'm going to make this improper. I'm going to make this 9 over 2, 7 over 2, negative 1/2, and negative 1/4. So when I multiply this across, I get 63 over 32, which gives me 1, and 31 over 32, which is about 2. So I'm going to go ahead and add in those additional points. So this one's going to go way up here. So it's negative 2 and 84. Over here, this goes to about 2. And then over here, this one for the 3 is down to negative 216. So again, all I need to do is see your additional points and just put labels on them. So I'm going to go ahead and connect them. Remember my end behavior. This far left 0 is going down. This one's going up. So we'll go ahead and connect these points. And there's your graph of that polynomial function. Let's do one more. Again, this time it's already factored for us. So again, I need to list possible zeros. So my possible zeros, but first I should take a look at this. I could actually factor it. So I'm actually going to factor this by grouping. So I'm going to make a group here and here. And this is going to give me x squared and then x plus 1. I'm going to factor out a negative 36 out of the second group. And again, it gives me x plus 1. I end up with x squared minus 36. And also the other is x plus 1. So I can factor this one further. And then now to find my 3 zeros, x equals negative 6, x equals positive 6, x equals negative 1. My y-intercept, I can plug in 0. And once I plug in zeros for each of my x's here, I get 0 here, plus minus 0, minus 36. So my y-intercept will occur at 0, negative 36. I'm now going to take these points, add them to the graph, negative 6, negative 1, positive 6, and then my y-intercept of negative 36. Again, you need to find additional points. I'm going to plug in negative 3, 1, 1, negative 36, negative 36, bring down, multiply, 6, negative 30, positive 90, and I get 90 minus 36. 54. So an additional point here will be -3, positive 54. So it'll come up, down. I'm going to use my y-intercept, and again, up to here. The homework for this lesson, again, this was a typo. It should be page 343 and numbers 21 through 41 odd. And that concludes lesson 3-4.